When Voyager 1 launched on September 5, 1977, it was meant to be a 5-year mission aimed at exploring Jupiter, Saturn, and their moons. But no one could have imagined what would come next. Fast forward 48 years, and this spacecraft has ventured farther than any human-made object in history, over 24.8 billion kilometers away from the Sun, and counting. Its mission is to boldly go beyond the boundaries of the solar system and unravel the mysteries of interstellar space. NASA's Voyager 1 spacecraft is the most distant human-made object in space. It's currently drifting more than 14 billion miles away from Earth, a staggering distance that continues to grow with each passing day. In 2012, Voyager 1 crossed into interstellar space, leaving behind the heliosphere, which is a protective bubble created by the Sun's solar wind. This marked a historic moment in the story of space exploration, proving that something we made could reach beyond the influence of our Sun. It's incredible to think that a spacecraft launched in 1977 with technology simpler than today's pocket calculators is still functioning more than 4 decades later. The original mission was designed to study Jupiter and Saturn, but the spacecraft continued its journey far beyond the initial plan. Voyager 1 still sends data back to Earth even today. The signal, transmitted using just 23 W of power, is weaker than a refrigerator light bulb, yet it travels across space at the speed of light, taking over 21 hours to reach us. On board the spacecraft is the famous Golden Record, a time capsule that holds Earth sounds, greetings in 55 different languages, and a collection of music from cultures around the world. It's a gift for any intelligent extraterrestrial life that might find it, offering a snapshot of what Earth is like. This record contains natural sounds like thunder and birds, greetings from world leaders, and even a human heartbeat. It also has music by composers like Beethoven and Chuck Berry, showing the variety and beauty of human culture. Voyager 1 was launched just 16 days after its twin, Voyager 2, as part of a mission called the Grand Tour. It took advantage of a rare planetary alignment that only happens once every 176 years, making it possible to visit all the outer planets using gravity assists. These gravity assists allowed the spacecraft to slingshot around each planet, using their gravity to gain speed and change direction. This clever technique made it possible to visit distant planets like Neptune in just 12 years instead of 30. During its journey, Voyager 1 and its twin revealed stunning details about the gas giants and their moons. They discovered volcanoes on Jupiter's moon Io and geysers on Neptune's moon Triton, proving that moons could be geologically active. One of the more recent findings from Voyager 1 is a faint hum detected in interstellar space. This hum comes from the interstellar medium and was picked up by its plasma wave instrument. It turns out that space isn't truly silent after all. The sound resembles a low hum caused by charged particles drifting through space. Scientists use this hum to study the density of the interstellar medium, giving us clues about what lies between the stars. Despite its age, Voyager 1 continues to provide valuable information. With only 69 kilobytes of memory, that's less memory than a single image on a modern smartphone. It's still collecting useful data. The spacecraft runs on power generated by a radioisotope thermoelectric generator, which converts heat from decaying plutonium into electricity. This power source is expected to last until about 2025, after which the spacecraft will go silent and continue drifting through the galaxy. Even after it stops communicating, Voyager 1 will keep moving through space, carrying our message to the cosmos. It will travel through the Milky Way for billions of years, long after Earth is gone. Over the years, Voyager helped us learn about more than just planets. It detected lightning on Jupiter, strange magnetic fields on Uranus and Neptune, and a massive hexagonal storm on Saturn's North Pole. Crossing into interstellar space wasn't like hitting a wall. It happened gradually, as scientists noticed changes in cosmic ray counts and plasma density. These shifts signaled that the spacecraft had left the influence of the solar wind. Interestingly, while scientists expected a shift in the direction of the magnetic field when Voyager entered interstellar space, it didn't happen. This suggested the Sun's influence might stretch farther than we thought. Voyager's systems have survived intense space radiation and freezing temperatures. Its antenna continues to stay perfectly aimed at Earth using gyroscopes and thrusters despite the extreme conditions. Even though it takes days to send a command and receive a response, Voyager has managed to avoid critical failures. Its simple and robust design has kept it operational for far longer than expected. Its tape recorders, designed in the 1970s, still work. Its old software still runs, and every bit of data it sends is treated like a gift by scientists who study the edges of our solar system and beyond. The Voyager missions aren't just about space science. They symbolize the powerful curiosity of humankind. These two tiny spacecraft carry more than instruments. They carry messages of peace, hope, and a detailed map pointing back to Earth. Some worry about alerting potential alien civilizations to our existence, but the Voyager team believed the risk was worth it. If for them exploration meant more than collecting data, it was about reaching beyond what seemed possible and sparking the imagination of future generations. Every signal from Voyager 1 is a quiet triumph of human ingenuity as it moves deeper into interstellar space. It encounters particles from long-dead stars known as supernovae. These particles are like fingerprints helping scientists understand how stars are born, live, and die. Even though the instruments on Voyager are old, they still work well enough to detect this cosmic dust. Each bit of data offers a small piece of a much bigger puzzle, helping astronomers learn more about the structure and history of our galaxy. The cost of the entire Voyager program was about $865 million at the time. Adjusted for today's money, that's around $4 billion, a tiny amount compared to many modern space missions, yet the value of the science return is beyond measure. Thanks to Voyager, we now know that long-duration missions in deep space are possible. The lessons from Voyager helped lead to other missions like New Horizons, which visited Pluto and continues to explore the Kuiper Belt. Voyager's success also highlighted the importance of backup systems. Both Voyager spacecraft have backup thrusters that remained and used for decades. In 2017, engineers successfully tested them on Voyager 1, proving they could still change the spacecraft's orientation. This unexpected success extended the mission's lifespan, once again proving that smart planning and simple design can lead to amazing results. NASA engineers continue to find ways to stretch every ounce of power and performance from the aging spacecraft. As Voyager 1 gets farther away, its signal grows weaker, but NASA's Deep Space Network, a system of massive antennas on Earth, listens carefully. Advanced software helps filter out background noise so that even the faintest signal can be understood. Without this technology, Voyager's tiny voice would be lost in the universe's quiet roar. These massive antennas are like cosmic ears picking up whispers from the edge of the solar system. The spacecraft's durability is another reason for its long life. It has very few moving parts, which means less wear and tear. Its systems were built to last, even though no one expected them to survive this long. Voyager's speed is impressive. It travels at about 38,000 miles per hour. Still, even at this speed, it would take 73,000 years to reach the nearest star. It won't survive that journey, but it's heading in that direction. Eventually, Voyager 1 will pass through the Oort cloud, a distant shell of icy objects surrounding the solar system. That journey will take about 300 years, and it'll take 30,000 more to exit the cloud completely. The golden record on board was created by a team led by Carl Schahn. They chose 118 images that represent life on Earth, from DNA structures to families and city streets. The record also includes audio like the sounds of rainforests and traffic. One of the most touching inclusions is the brainwave recording of a woman in love. This bit of human emotion sent into the vastness of space shows how the mission was as much about art and spirit as science. After leaving the heliosphere, Voyager found that the interstellar medium was denser and more active than scientists had expected. This discovery changed how we think about the space between stars and how galaxies evolve over time. The information helps researchers understand how cosmic radiation moves through space, which is important for protecting astronauts on future deep space missions. The Voyager data continues to influence plans for exploring beyond the solar system. Perhaps one of the most famous moments in Voyager 1's story was in 1990 when it turned its camera back toward Earth. and captured the iconic image known as the pale blue. In the picture, Earth appears as a tiny speck suspended in a sunbeam. Carl Sagan's reflections on the photo became legendary. He reminded us that everyone who ever lived exists on that small that the image became a symbol of our shared existence and the need to care for our fragile planet. As the spacecraft runs out of power, its instruments are being shut down one at a time. To conserve energy, already tools like the plasma spectrometer and infrared sensors have been turned off. Soon, only a few key detectors will remain active. NASA engineers carefully decide which instruments to power and which to retire. Every choice is based on how to keep collecting useful data for as long as possible. They're squeezing out every last bit of science before the spacecraft falls silent forever. Incredibly, even after years of inactivity, the spacecraft's thrusters responded when activated. This gave the mission a new push and showed once again that good engineering can stand the test of time. The region Voyager is now exploring is far from empty. It contains dust, magnetic fields, and neutral atoms. Voyager's readings show how these elements interact, shaping the galaxy's environment and affecting how stars are formed. Thanks to Voyager, we now know that this space isn't lifeless, it's active and dynamic. The spacecraft's success has inspired ideas for future missions like the Interstellar Probe, which could explore even farther, though such projects are still many years away. Until then, Voyager remains our only window into the mysterious space between the stars. Its journey was made possible by a rare alignment of planets and the brilliant minds who designed it to last. Voyager's story lives on in books, films, and music. It has become a symbol of our desire to explore, to learn, and to connect with the unknown. Even after its power is gone, it will keep traveling, carrying with it the story of Earth and its people. Subscribe to our channel, and thanks for watching.